Hello friends, this is Sabir Moin Sheikh, faculty Vidyalanka School of Information Technology. In today's lecture, we will be discussing program status word of 8051 microcontroller. It is also called as PSW. Firstly, we will discuss the purpose of PSW. PSW contains status bits that reflects the current CPU state. PSW is an 8-bit register. Although PSW is 8-bit wide, however, only 6 bits of it are used by 8051 microcontroller. PSW is also called as flag registers. These flags are called as conditional flags, meaning that they indicate some conditions that results after an instruction is executed. There are 4 flags. First, carry flag, which is also called as CY flag. Second, auxiliary carry flag, known as AY flag. Parity flag, also called as P flag. Overflow flag, that is OV flag. Apart from this flag, condition bits D3 and D4 are named as RS0 and RS1 respectively. These bits are used to select different register banks available in 8051 microcontroller. Bit D6 is a user-defined bit which is used by the user to define a specific task or an operation. Now we'll see how the actual structure of PSW looks like. In this we can see that the program status word, which is of 8-bit, where each bit is given its position. The first bit is D0, D1, D2, D3, D4, D5, D6 and D7. All these bits are also called as PSW.0, PSW.1, PSW.2, PSW.3, 0.4, 0.5, 0.6, 0.7, and each bit has certain function. Let's discuss all these bits one by one. Firstly, we'll discuss bit D7, which is also called as PSW.7 or carry flag. This flag is set whenever there is a carry out from D7 bit. Let's see this bit with an example. In this example, we can see that there are 2 8-bit numbers which are being added. So when we see that when all these bits are added, there is a 9th bit which is generated. So while addition in this example, the 9th bit that is generated is called as carry. This carry bit sets the carry flag to 1. However, if this bit wouldn't have been generated or the result in this carry bit would have been 0, then carry flag would have been reset. The carry flag can also be set to 1 or 0 directly by instructions called as STBC and CLRC respectively. STBC means set bit carry, while CLRC means clear carry. The next bit that we were to discuss will be bit D6, that is also called as PSW.6 or auxiliary carry flag. Referring to the same example, in this example we see that there is a carry generated from bit D3 to D4. Now in this example we see that the D3 bits are 1 1. When this 1 1 are added, the sum is 0 and carry is 1. So this carry is being transferred from D3 bit to D4. Due to this, auxiliary carry is generated, and the auxiliary carry flag is set to 1. If in case while addition of this D3 bits there is no carry generated from D3 to D4, the auxiliary carry flag will be set, or we can say it will be reset to 0. The next bit in discussion is bit D0 or PSW.0 or parity flag. Again, if we refer to the same example that we had used, after the additions of both the 8-bit numbers, the number of 1 present in the result, leaving the carry bit, is counted. If the number of 1 counted in the result is odd, then the parity flag bit is set to 1, and if it is even, it will be set to 0. Now in this example, in the result, if we count, there is 1, 2 and 3. There are 3 ones which are present in the result. So the result carries 3 ones in the result. That means the parity flag will be set to 1. The example taken over here for carry flag, auxiliary carry flag and parity flag is addition. However, the same condition holds true if the operation was subtraction. The next bit is bit D2 or PSW.2 or overflow flag. This flag is set whenever the result of a signed number operation is too large, causing the high order bit to overflow into the signed bit. This flag is basically used when we set a counter. Suppose we have set a counter in the timer as 20H. So when the counter completes the count of 20H, then the counter, the overflow flag will be set to 1, which shows that it has come to the maximum number of operation and the next count cannot be stored. This is how overflow flag is set to 1 or 0. Next bit in discussion is bit D3 and D4, which is also called as PSW3 and PSW.4. This bit are basically used as a register select bit. At a time of registers can take values from R0, R1 to R7, and since we already know that there are 32 such registers, how do we access all these 32 registers using just 8 variables to address registers? Here comes the use of register bank. There are 4 register banks named as bank 0, bank 1, bank 2, bank 3. Each bank has 8 registers named R0 to R7. At a time, only one register bank can be selected. The selection of register bank is made possible through these two 8 bits named as RS0 and RS1. These bits are also called as register bank select bit, as they help in selecting the desired bank. So, if we put the values as 00, then register bank 0 is selected. If the value is set to 01, then register bank 1 is selected. If the value is 10, register bank 2 is selected. And if the values are 11, then register bank 3 is selected. In case no values is put in RS1 and RS0, by default it takes the value as 00, which indirectly select bank 0 as a register bank. Next bit in discussion is bit D5 or PSW.5. It is a user-defined bit which is basically used by the user to define a specific task or operation. The last bit that we have to discuss is bit D1 or PSW1. This bit is basically reserved for the future use. So in all, we have discussed all the bit positions which are there in program status word. Hope you have understood the entire concept of program status word. This is how the final stature of the program status word looks like. So I hope everyone has understood the entire concept of PSW. Thank you. Have a nice day.